NAWAPA's construction itself requires enormous amounts of material, equipment, and skill. And since we will not be squeezing materials out of the continent's currently dying state of infrastructure and industry to build it, but using it to cause a fundamental transformation of our current management and understanding of human economics, the transportation of all of those needs into the regions of NAWAPA require new and improved logistical supply lines. 3 main areas are involved, all of which can be constructed simultaneously. First, the refurbishment of those existing and the addition of new rail lines from a revitalized industrial heartland out to the west. Second, the construction of the new Alaskan-Canadian rail system, which will connect Alaska with the rest of the continent by rail for the first time, and will be crucial for the northern components of the NAWAPA system. Third, management of the North American water cycle through NAWAPA, and these implied development lines further imply the obvious economic integration of the Eurasian and North American landmasses through a new Bering Strait rail system. Immediately, existing rail lines can be upgraded and electrified. In the medium term, given that much of the NAWAPA system is located in mountainous regions, the construction of magnetically levitated rail systems will provide a great benefit. Maglev technology is a fundamental advance over the old push and pull technology, and can move up much steeper grades than conventional rail, which will be a great advantage for moving the supplies required. The construction of the NAWAPA system will necessitate a reindustrialization of the Midwest. The design designates that construction will begin with a dense collection of large reservoirs, tunnels, and pumping systems to be built in Idaho, and a 500-mile main storage reservoir in southern British Columbia. We will first look at the rail connections between these first stages of NAWAPA and the Midwest. This will involve mainly the Union Pacific Railroad and the Burlington Northern Santa Fe Railroad from the Midwest into Idaho, and the Canadian Pacific Railroad into southern British Columbia. To be able to handle the materials necessary for NAWAPA and related support centers, the Union Pacific would have to be double-tracked in Iowa and western Illinois. Across Wyoming, it is presently double-tracked and will need a third track. As it approaches Idaho, where it is primarily single-tracked, it will need to be double-tracked all the way out to Portland, Oregon. The Burlington Northern Santa Fe Railroad is all single-tracked and will need double tracking, especially as it crosses Montana. Additional rail lines across the Bitterroot Mountains will be needed. A few choice routes along the Canadian Pacific Railroad will also need double tracking. The construction of these supply lines alone, long before any construction would begin on NAWAPA itself, along with the gearing up of national industries to produce and design the needed supplies to be hauled along these routes, would be enough to reverse the current tidal wave of physical economic collapse and ongoing disintegration of the United States, and employ and restore decency to the 35% of construction workers, skilled laborers, and engineers who are currently unemployed. The duration of the development of these Midwest lines and the estimated 5-year construction of the transfer function of NAWAPA will cover the lead time for preparation of the collection function of NAWAPA and be accompanied by the simultaneous construction of the Canadian-Alaskan Railway, whose main route is estimated to take 5 years and can be begun immediately since it has been rigorously studied and planned out under former Alaskan Governor Murkowski and other private studies. Some ways north of Prince George, British Columbia, a city which will become a major center through its role in managing the Upper Fraser Lift of the NAWAPA system, the present Canadian Railway ends, a 250-mile line currently for sale by the government of British Columbia for $1. From there, and just north of Dawson Creek, 2 single-track lines to Fairbanks will be built to connect Alaska and the Yukon Territory with British Columbia for a total of approximately 2,000 miles of rail. The first to be built runs from Dease Lake through Jake's Corner and Whitehorse, with its main line continuing near Tok Junction and on to Fairbanks. The next line built will run from Fort Nelson, a major urban center of the future, past Watson Lake in the Yukon, and from there to Pelly Crossing and Dawson, before crossing into Alaska and making its way to Fairbanks. Despite some rerouting that will be needed, the eastern line from Fort Nelson will serve well for the construction of the Liard River Dam, as well as passing right through Dawson, supplying materials for the construction of the 900-foot Dawson Dam of the NAWAPA design, and other dams forming the Yukon and Eagle reservoirs. The Dease Lake line will aid in supplying materials for the construction of the 5 Stewart dams of Nass Reservoir. And further north, once the line is rerouted east of the Tanana Valley, this line will be perfectly situated for supplying the construction of the 30-mile-long Alaskan Tunnel and Tanacross Dam of the NAWAPA design, as well as serve as a possible source for a new line toward the Copper River Valley. These routes not only lend themselves to servicing the development and regulation of NAWAPA, but signify a grand reorganization of the political, cultural, and mental powers of human economy. And while they are under construction, another major development will be underway, the thoroughly planned out Chukotka Alaskan Railway, crossing the Bering Strait. From Fairbanks, the rail line follows the north side of the Yukon River, crossing the Tanana River after Manlay Hot Springs. The rail continues along the north side of the Yukon through Tanana to Galena and Koyukuk. From there, the route continues at a maximum elevation of 1,300 feet through several tunnels over and through the Koyukuk Mountains to Haycock. There will be a branch line from Mary's Igloo to Nome to a future expanded port to support construction of the corridor and tunnel project. Across the western end of the Brooks Mountain Range, the rail corridor continues out to Wales along the southern part of the Seward Peninsula, named after Lincoln's faithful Secretary of State, William Seward, who the British organized assassins had also meant to kill the night they assassinated Lincoln, but who survived that stabbing to later ram through the Alaskan Purchase in 1867 after a sleepless night of drafting the proposal with Russian Foreign Minister Edward Stoichel passed through Congress the next morning. Meanwhile, Russia will be building its side of the Bering Strait project to receive and deliver products and materials across the Bering Strait. The proposed Bering Strait Railroad crossing between Uelen and Wales, either by bridge or tunnel, would have a length of 65 miles. The total line between Egvekinot and Fairbanks is a 975-mile route. Through direct and indirect construction, related power and transportation requirements, and involved industries, the Alaska-Chukotka Railway will employ 1 million people in Russia and China and 1 million people in the United States and Canada. In order to accommodate the increased traffic on the Alaska-Canada rail network, whose estimated tonnage hauled will increase 4 times through the creation of the Bering Strait crossing, all the main routes will be double-tracked, as well as a 1,240-mile stretch of triple-track between Whitehorse, Yukon Territory, and Wales, Alaska, and a 270-mile stretch of triple-track between Uelen and Egvekinot. This doubling and tripling will take roughly 5 to 10 years. The total expected traffic capacity of the railroad is approximately 150 trains per day, which is equivalent to a volume of 300 million metric tons per year through the Bering Strait Railroad, equivalent to the current amount carried on the most heavily traveled railroad line in the United States between O'Fallon and Gibbon, Nebraska. The development of these logistical supply lines along and related to NAWAPA's route imply much more than first meets the eye. NAWAPA's own and related establishment of permanent civilization in the northern regions of the North American continent opens up mankind's access to a more complete knowledge of the Earth's crust and its incorporation into technological advancement. For the past 2 centuries, the British Empire has been the expert on extracting resources on the backs of local populations. These resources are immediately shipped out to the coast for export, with no economic improvement of the local regions. The destruction of the land and the painful conditions those people endure is blamed by environmentalist agencies of the empire on overpopulation. In contrast, the path of true resource development, guided not by imperial policy but by sovereign nation-states, proceeds quite differently. Built into the law and purpose of the sovereign nation-state is the organization of society around the unique power of human creativity. Through human discovery, the hidden characteristics of the elements of the Earth's lithosphere and biosphere have been turned into a form usable by humans through invention and technology. Natural resources are in fact cognitive ones. Coal was not a resource for man until he added it to his arsenal for high-temperature industrial processes, whose value further changed with the invention of the steam engine. While crude oil was not a resource until the petroleum revolution of the 19th century. Today we look forward to using thorium as a resource in super-efficient nuclear reactors, and beyond that, to resources for nuclear fusion. As human civilization progresses, the products of the lithosphere and biosphere only become valuable relative to the technologies and levels of infrastructure made available by human discovery. As new discoveries are made, their relative value continues to change. New types and concentrations of raw material are made refinable through higher energy flux dense heat sources and transportation technologies. The consumption of one kind and source of resource must be used to directly fuel progress toward the ability to increase the density of mankind's technological organization of society. Therefore, unlike the looting done through British Empire methods, emphasis will be put on the organization of new infrastructural conditions, with the power to create a permanent human presence in these regions, a transformation in which these resources will play a valuable role. Rail will be strategically routed, not just to working points along the NAWAPA, such as pumped lift sites and major dam and power construction, but also through areas potentially dense with useful resources. After the single track of the Alaska-Canada rail link is completed, 5 or 10 years from now, and the Bering Strait rail connection nearly completed, new routes can begin construction. One line shall be built from Kayukuk through Red Dog to the coast at Point Lay. Along this route, sulfur, zinc, potash, and gold will be mined, as well as a potentially enormous load of uranium and thorium that can be explored and developed. Red Dog is currently home to a zinc mine, and Point Lay is in the middle of massive coal fields which represent the fossilized solar rays captured by plants 400 million years ago during the Carboniferous era. Both of these mines must be expanded and developed immediately. Through the newly opened Bering Strait rail passage, China, our partner in global progress, will benefit greatly from these deposits, both in immediately bridging their 40% deficit in national tonnage of coal production with a much cleaner, low-sulfur, high-grade Alaskan coal, and cheap access to the needed material for their future transition to a fully nuclear economy. The planned 420-mile oil and natural gas line from Fairbanks to Prudhoe Bay will also serve to drive the development of valuable metal ores located across the Anaktuvuk Mountains, such as the copper ores created through reactions generated by decomposed organisms 500 million years ago. Russia's large contribution of petroleum from the Chukotka fields would meet the main line at Fairbanks, which would continue on through northwestern Canada, where Yukon contributions would be brought down via a line from Inuvik, with the whole collection passing through Fort Nelson and continuing south. Finally, the petroleum resources would be refined in southern Canada as well as in North Dakota, and large quantities could serve the lower 48 as industrialization is revived. The main route of shipment from Prudhoe Bay to Calgary would be 2,800 miles long. A pipeline is also needed for the giant Athabasca tar sand deposits, where the steam byproduct from reconfigured nuclear reactors could be used to efficiently extract petroleum. A crucial driver of these developments will be the Bering Strait Railroad, making it possible to ship containers by rail between the interior areas of Asia and North America entirely by land, with time savings of 5 to 10 days or more, as compared to existing marine rail intermodal combinations across the Pacific Ocean. Finally, as these initial areas become completed, a second and third phase of new rail lines and resources will be extended into the Yukon, Northwestern Territories, and Nunavut. Planned out in detail, the second phase will create easy access to one of the world's largest iron deposits between Dawson and the new industrial center of Fort Norman, as well as other strategic locations throughout the Northwest Territory, such as the future Yellowknife. The third phase will continue development throughout Nunavut. These rail systems will work directly with the NAWAPA design to expand new waterways into various Canadian regions rich in resources, opening up these places to cheap water transport, including routes all the way to the Pacific, exiting near Vancouver and to the Arctic via the Liard and Mackenzie rivers. Starting from the east in the iron mines in Newfoundland and Labrador, over half of Canada's total iron ore is produced. These, along with other mining and forestry, will benefit from cheap water transport. The same will be true for Quebec and Ontario, where there is intensive gold, iron, titanium, copper, zinc, and silver mining. The Knob Lake Barge Canal will connect this eastern region into the new James Bay Seaway, the Great Lakes System, and existing waterways. Through Manitoba, the Hudson Bay Seaway will run down to the Canadian Great Lakes Seaway, which, along with the Dakota Canal, will expand these new and existing transport routes through the prairie provinces of Manitoba, Saskatchewan, and Alberta, where NAWAPA water will provide 22 million acre-feet of water per year to greatly expand the existing agricultural and ranching potential of the region, as well as open up major potash mines in Saskatchewan. The seaway then continues west to enter the Pacific near Vancouver. The value of these resources is not self-evident in their existence alone, but defined by their aid in the establishment of mankind's permanent presence in these regions, which will become home to populations that specialize in developing the expertise in extracting, refining, and using these resources located nearby. These rail lines, canals, resource developments, related industries, and cities will not be individually built for the business profit which they will generate, and will not each separately pay for themselves. Rather, by its planned functionality in relation to the direction and purpose of the whole, each separate investment contributes toward the increase in productivity of the system as a whole. This leads to a determinate, guaranteed increase in the potential relative population density, which, for the human species means affecting the goal of an increasing power and rate of creative discovery and active mastery of new principles for creativity's further use. All of these developments make the possibility of bringing the full continent under the directed management of the sphere of human cognition a reality.